And, ladies and gentlemen, it's my pleasure to introduce Paul Brody from Ernst & Young, or EY as they call themselves now, who will be our afternoon keynote speaker. Paul?
Thank you very much, Arthur. So, hi everyone. For those of you who are back from lunch, it's good. I haven't even said anything yet. I found the clicker excellent, and we have slides because I'm an American and I don't really know how to give a presentation without slides. I hope everybody had some coffee. I'll try not to bore you. So I'm Paul Brody. I'm the technology sector strategy leader at Ernst & Young, and joined EY about 9 months ago from IBM, where I ran global electronics. And if some of you know my name, it might be because you read about some of the work I did at IBM in the creation of the first Internet of Things platform built on BitCoin and the blockchain. And as we go through this presentation, I'll tell you a little bit about how I came to think about the Internet of Things, how I came to think about the kinds of platforms and technologies that should drive it, and where I think return on investment comes from in this space. And all of this started with a search for a smart toaster, right? So if we think about the appliances that we have at home, I found this, I talked to a lot of appliance companies as a consultant, and one of the things I always say is, well, what kind of technology, what kind of Internet of Things capability, how can we make our appliances smart? And I had the CEO of a big appliance company tell me, well, this is great, we have this idea. You'll be able to start the oven remotely. This is, without a doubt, the dumbest idea in history. I mean, first of all, are you going to leave the chicken in the oven all day? That sounds like a great way to get food poisoning without the oven on, right? Then you're going to switch it on remotely, and you're going to get stuck in traffic, and probably, the entire house will burn down, right? It sounds like a nightmare. And what I came back to this question of was that if we are going to make devices smart, why are we making them smart? And I think if we talk about consumer devices, I just want a toaster that does not burn my toast. Right? You know the little knob on the side that shows you how brown it is? That is a placebo. Doesn't actually work, right? It's just a timer. And so we talked about, can we make a smart toaster? And the answer is apparently nobody at IBM was interested in making a smart toaster with me. But we did end up spending a lot of time thinking about the Internet of Things. And then since I've joined EY, I've had the privilege to do even more thinking. And so what you see here is a bit of kind of a refined thinking about where does ROI come from, and where does productivity, where are we going to drive productivity? So that's what I'm going to talk about today. So where is the next big productivity revolution coming from? So first, I'll just spend a few minutes. I want to talk about kind of the history, looking backwards. Where have things been? Secondly, let's talk about productivity. And then third, what are the ingredients we need to drive this productivity revolution I imagine is going to come? And then finally, what do I think the key takeaways are going to be for industries, right? And therefore, that means both opportunities for startups as well as opportunities and threats to existing large enterprises. So let's start with history, because if we can't remember history, we're going to have a hard time thinking about the future, I think. And what I like is, let's talk about cycles of innovation and disruption. It's our favorite word here in Silicon Valley. I live literally 5 minutes from here. This is the closest I've ever been to home for any kind of a work-related activity. I'm so used to traveling. But so this is a picture of one of my kids helping to pay for the Woodside Elementary. No. So the first industrial revolution dates from the 1780s. And at that time, it was all about textiles. And in the 1780s, it took roughly, I think it was 2,000 hours to process 100 pounds of cotton. By 1820, they had managed to reduce that by 90%. Right? So 40 years for an industrial revolution, and this was a great measure of that. This is what happened to the global textile market. Britain, which had been a major importer of textiles and a relatively minor player in the market, basically steamrolled the entire global market. This looks like what Uber did to Yellow Cab, right? I mean, except it took 40 years instead of 4 years. But 90% productivity improvement, over 40 years, completely changed the landscape. We had another industrial revolution a century later. Henry Ford brought it all together around the Model T. Again, we had this huge increase in productivity, right? When he first put the Model T on an assembly line, it took 14 hours to assemble one Model T. 7 years later, he had it down to 90 minutes. Another 90% productivity improvement. And I will argue, and I do argue, that if we can get a 90% productivity improvement, that's how we know that we are really achieving a kind of industrial revolution class of activity. And that was the last industrial revolution we had. Since then, economic growth, productivity growth has actually gradually been slowing, right? And it's been slowing in part because we've been shifting from manufacturing to services. Most of the global economy is in services. That includes consulting and accounting, things that we do at EY, right? And if we look at the service sector data, and this is some good data from the UK, but it's no different in the US, IT growing productive very nicely. Manufacturing, productivity still growing. Services, hardly budging. Right? The service industry, if we want to have another industrial revolution, if we want to have another massive transformation, it's going to have to be in the services sector. We need a service sector productivity revolution. Now, I had some professors in college who argued that this is really not possible. Let's think about a string quartet. Can we lay off one member of a string quartet? It's not a quartet anymore, is it? Do we want them to play faster? No. Right? So there are some people who say, you know, some services are kind of irreducible in their fundamental nature. But I think that's really taking way too narrow a view. If you step back, the actual amount of time that a string quartet spends playing in front of an audience is very small. Right? In reality, most of the other stuff they do is compressible, it is addressable, right? And I actually really believe that this is what the Internet of Things is for. It's for driving productivity in the service sector. And in particular, I believe there's two use cases that will be transformational. The first is asset utilization, right? So what do I mean by asset utilization? I mean the utilization of the physical assets that we have in the real world. The amount of assets that we have is staggering, right? I mean, short of having a really big thermonuclear war, we keep accumulating assets, new buildings, new cars, all kinds of stuff, and we're terrible at using them, right? Dishwashers, 4% of the day. My favorite is the car. The average car is in use only 4% of the day, right? Now, by the way, the average New York City taxi is busy 50% of the day. So as a shared asset is 10 times more productive than a privately owned car, right? Office space, 20% of the day is the average utilization of a piece of office space, right? MRI machines. This is a piece of capital equipment that costs in excess of $1 million, and here in the US, the average MRI machine is busy for less than 25% of the day, right? New York City taxis. This is the benchmark. We know this because the New York City Taxi and Limousine Commission is obsessed with statistics. So we have data. And even commercial airplanes, only, you know, probably the highest level is about 60%. So what do companies like Uber do, right? They are really turning digital, they are connecting digital assets and they are turning them into real-time marketplaces, right? So you can see where the assets are, you can see where the demand is. They are creating a market for a shared asset, right? And so this idea of the Uberization of assets, I think, is critical, right? Everybody here in the Valley runs around taking, you know, proposing, you know, I have the Uber for this and the Uber for that, right? And that should be enough to get you like 20 million bucks right there. Now, I confess here, I have a little bit of a thing against VCs. I left IBM in 2010 to start my own online movie company. And the VC at that time told me, he said, come back when you're cash flow positive. And I was very polite, and I said, I'll think about it. But actually, we got sued into bankruptcy, so that eventuality never occurred. And after failing spectacularly, I went back to IBM. Because I know how to navigate a large, soul-crushing bureaucracy. But that's what companies like Uber are doing. And it's not just Uber, right? Airbnb is integrating with technologies like Unikey, right? We are taking smart assets and putting them to use to make our larger physical assets more valuable, right? So I have a place in San Francisco which I used to rent out on Airbnb, but I no longer can for less than 30 days. But the best investment I ever made in any kind of smart asset was a smart connected door lock. Right? I can give guests a code. I don't have to meet them. I can give the cleaners a separate code. Right? The ability to connect that into Airbnb directly means that the whole process compresses. The amount of time I can get that asset busy goes up. Right? And that's where I think this huge amount of opportunity is. So if you take all of these assets that we're starting to instrument, the process that I believe we're going to see is a fairly straightforward one. When we instrument an asset, when we make it smart and connected, the first thing we're going to realize is, wow, we are not using this asset very much. Right? That is almost universally true. And what follows then is optimization, right? Can I use this more? Can I get my company to use it more? But eventually, what people will do is they will put those assets into a digital marketplace, right? Instrumentation, optimization is almost always followed by monetization. And what we will end up with, I believe, is what I call the economy of things, right? Not the Internet of Things, but the economy of things, where every asset that we own will participate in many multiple online digital marketplaces. And the main value prop will be asset utilization. And to illustrate that, I want to show you some sample returns on investment, because they're really amazing. A lot of times, and I work a lot in IoT, and so I talk to a lot of companies about what their vision is for IoT and how they're going to do it, and everyone loves to talk about predictive maintenance. I am sick of predictive maintenance. There is no fantastic ROI on predictive maintenance. And everybody loves to pull up like oil platforms. Yes, okay, you pick like one of 3 cases where it's worth, $1 million a minute for downtime, right? Airplane engines. The truth is, most physical assets are so reliable. Cars, other physical assets today, that the return on investment is actually pretty marginal for predictive failure, right? If failure was predictable, it would have been engineered and repaired. We make incredibly reliable assets. That's why we get, 100,000-mile warranties on our cars, right? In fact, it turns out that, and this is analysis that we've done, basically the return on investment for predictive maintenance is 10%. And that's 10% not on the device as a whole, but 10% on the value of the incremental spend for making it connected and smart. That's okay, but the problem is that that spend to make a device connected and smart is trivial. It's trivial, it is non-strategic. All right. Now, much better return, energy efficiency, right? That's the other one that people love to talk about, right? It's great. Nest is a really good example. They talk about 50% return on investment. The truth is that if you were to look at the Pareto of energy consumption, that's it. Heating, heating is the source of it. Maybe next one is hot water. That's it. Right? It's actually cheaper just to leave your LED light bulbs on than to put in one of those motion sensing switches. So energy efficiency, better, but still not a strategic ROI. Asset utilization, though, now we're talking about strategic ROI, the kind of ROI that shifts balance sheets numbers. And a great example of this is Getaround, right? The average person who puts their car in Getaround generates about $300 a month. That's an 1,100% annual return on investment. And more importantly, that is meaningful not just in the context of the cost of connecting the device, that starts to be meaningful in the context of the cost of owning or acquiring the device. Right? Now, some of you are going to say, these are just anecdotes. They're not anecdotes. This is California. These are small batch artisanal data points. But I think they illustrate patterns that we see over and over again, which is that the return on investment for asset utilization dwarfs almost every other business case. So that's one of the business cases. The second business case that's really interesting is cycle time compression. And I'll illustrate that in the simplest way I know how. Today, it takes longer than 90 minutes to make a car. But if you go to BMW or these Ford, other places, you can make a $100,000 luxury car in somewhere between 40 and 60 hours from the time the first parts roll in the factory to the time the finished car rolls out the door. $10,000 for a bathroom renovation, you're looking at 4 months. Maybe longer in Woodside. Now, there we go. I clicked too fast. Now, my husband, he is an incredibly patient man. I have only seen him lose it once, and that was with the bathroom contractor. You know, it takes all these physical real-world services take way too long, right? The contractor shows up, he's like, oh, the toilet isn't here. Then the toilet arrives, he comes back, it's like I brought the wrong tools, right? I mean, before you know it, it's 4 months. And by the way, this is not just for bathroom renovations, right? I did some work with one of the world's biggest mobile network operators. And this mobile network operator, you know, they build, to build a new cellular network, you need to build like 20, 30,000 cell sites. A cell site, you can think of a cell site as a $300,000 bathroom renovation gone horribly wrong, right? They take months to complete. They're never done on time, right? It's a disaster. And the reality is that, you know, what Henry Ford was able to do in manufacturing, we struggle to do in the real world, right? He standardized process, he standardized components, and he synchronized all the resources. Car comes down the production line. Your job is to put on the door handles. You pick up the door handle from your little Kanban box. You put it on the car, and it moves on, right? That's sync process, component, and resource synchronization, right? But pervasive Internet of Things, pervasive IoT, makes it possible for us to start doing something that looks like that in the real world, right? We can't standardize process on a limited number, but we have software that can now remember thousands of processes and process variants. We can't standardize components, but we can now have a catalog of all the different ones. And it is possible, because people have been good enough to put smartphones in their pockets, to synchronize all the resources that are involved in complex service activities. And so what you end up with is, I think, another potential for a 90% productivity improvement. It is not uncommon to see a chart like this. If you do a process analysis of any kind of large enterprise activity, right? Theoretical time to do something, about a day. Actual average cycle time, 9 or 10 days, right? It is possible to compress real-world experience down to theoretical cycle times, even in services. And we see companies that are starting to do that, right? I just give you a couple of examples. Delta Airlines. They have the oldest airline fleet in North America. And old planes need more maintenance. And maintenance should mean more delays, but it doesn't. Delta actually has fewer delays than any other major US airlines for mechanical reasons. So they apply a disciplined approach to the process of maintenance, right? Another one that's favorite, in China, a construction company built a 57-story building in, I think, 19 days. And yes, it has bathrooms, right? It is possible to structure and manage service activities in a way that gets this level of productivity if we start to instrument and manage all the components in the process. So what do we need to do that? I think we need 3 things. Robert Solow said you can see the computer age everywhere but in the productivity statistics. That's because we haven't instrumented every part of this process, but we are getting there, right? First of all, we have connected ourselves, right? Everybody has a smartphone. But we need 2 other things. Number 1, connected devices, and number 2, digital processes and markets, right? When it comes to digital devices, connected devices, the great thing is phones, the appetite for smartphones, the billions of smartphones that we have out there, means that the cost of computing power has come down to a level where if you want to make any smart device, you can put an entire smartphone in it. In fact, that's an example of what the Nest is. But we've actually reached the point where it is cheaper and easier to make devices smarter than to leave them stupid. And the way we know that is the process at which embedded chips, the cost of making an embedded chip is now falling below the cost of just buying an incredibly smart off-the-shelf chipset. And we know this because even Apple, if you crack open some of Apple's cables, you won't find embedded chips in them. What you'll find are basically full-on dual-core system-on-chips with gigabytes of RAM and storage. Not because it's necessarily they need all that compute power, but because it's easier and faster to get to market that way. So we're now headed towards an era where it is cheaper to make devices smart and connected than stupid and disconnected. And that is absolutely transformational, right? That means no business case required. That was a big aha moment for me. No business case required to make devices smart and connected. And of course, we're already swimming in compute power, right? We have in data centers, Amazon, they have somewhere like 6 million servers, right? There are 2 billion phones out there. There's almost 1 billion PCs, right? The truth is, and start adding 10, 20, 30 billion more IoT devices that are all as smart as the original iPhone, we will be drowning in compute power. But we're missing one other technological capability, which is the ability to use this compute power, right? Why is all this compute power sitting there unused? Why is all this empty storage space out there? We don't know how to use it in a way that is secure and reliable. Spoiler alert from the title of this presentation, BitCoin, right? We need a platform that is secure, it's efficient, it's open, and it's designed for commerce. And I believe that that is what we really get by taking the guts of Bitcoin, the blockchain, and applying it to the Internet of Things. So what is the opportunity around the blockchain? I believe that what we get with Bitcoin is a platform for the most basic work in computing. That's the stuff computers have been doing since day one, transaction processing, right? What is Bitcoin? It's a bank and it's a currency, right? Banks just do transaction processing, right? So a like is a transaction. A tweet is a transaction. An airplane ticket is a bundle of transactions. What's in your utility meter? Utility meter readings, which, by the way, the first transaction processing system was made in 1966 for utility meter reading, right? This is the foundation of modern computing, except for now we can do it on every single device everywhere with no centralized infrastructure, right? 3 ways, many of you kind of know this, but I'll go into it. 3 things that really make the blockchain, this core technology of Bitcoin, unique from this purpose. Number 1, it's distributed processing, right? All the work in the blockchain requires no central computing architecture. When I was at IBM, we developed an Internet of Things network. It was a distributed advertising marketplace where you could buy ads, distribute them, and show them on Samsung large format displays. This entire marketplace ran on the embedded processors in the displays. Not one single server was required, right? And that's what you can do with the blockchain is every piece of work can be done in a distributed way across the entire network. Not only is the work distributed, but all the records are synchronized. And this makes the blockchain one of the most fraud and fraud-resistant mechanisms ever developed. Okay, so if you want to go back and rewrite history, not only do you have to be very good at cryptography and math, but your records are going to be out of sync with everybody else's. And that's going to be an immediate giveaway. And if we think about what we need in a modern computing environment, I would argue there is one thing that we need almost above anything else: trust. There's one thing that we have learned in the last few years is that you cannot trust anyone online. You cannot trust anything. All the organizations that were supposed to be protecting our privacy and security have not been doing so, right? In fact, they've been engaged in invading it, right? The blockchain provides a mechanism for preventing tampering and fraud that is almost unbeatable. And then lastly, the blockchain is different from traditional transaction processing in that you can send more than just data. You can send applications, right? And there are variants of the blockchain like Ethereum that are full programming languages. We can write cloud applications that run on internet-connected devices that require no servers. Why does that matter? It matters for a couple of reasons, but probably the most important one is no servers means no data center, which means no cost associated with that, right? And if you are a large enterprise trying to build a massive network, you're talking about tens of millions or hundreds of millions of dollars a year spent on centralized servers, which I believe fundamentally is unnecessary going forward. So what we end up with is what I believe is the single most secure computing environment ever developed, and it is the mechanism that I think we can use to tie all of these process and markets together and enable this productivity revolution. And that's exactly what's happening. So people are taking this core technology and they are applying it to all different kinds of services, from social networks to distributed medical records. Okay, let me just wrap up before they tell me to go away. Or anybody else falls asleep. Actually, I haven't seen anyone fall asleep. This is great. The coffee here is good. What are the big takeaways, right? Other than blockchain is a nifty technology, right? The future is already here, right? We're starting to see this, but I think there's 5 big things that we should look out for. Number one, capacity. There are a lot of industries where we talk about how much capacity is available in the industry. There's way more capacity hidden out there in so many industries than we have ever known for, right? What Airbnb did was they brought a ton of capacity into the market for hotels. And we're starting to see some great research that shows that wherever there's a large number of Airbnbs, hotels have not been able to raise their prices, right? MRI machines, average utilization of 25%. What do we think is going to happen to MRI pricing if a transparent, digitally connected market for MRI machines and MRI scanners takes place? They might go down a little bit. Office space, right? Every single major industry that I can think of, many of them are suffering from substantial overhangs of hidden capacity. Right? So if you're an investor, you might want to think about, can this asset be shared? And if so, what happens with a supply shock? Because there's a lot coming. Secondly, growth. One of the things that we've seen over and over again, and we're in the process at EY of doing a new study on this work, is looking at the growth in industries, what happens when these supply shocks occur. Right? And what invariably happens is as prices plunge, demand surges, revenue grows, profits do not. It's very important as we think about the opportunities here not to confuse growth with profitability, right? Innovation. As we come towards innovation, and people talk about why do some things take off? Why did Uber take off and not something else? I saw a great example not too long ago. Google attempted a service where you could order a taxi from your browser. Very cool idea, not that dissimilar to Uber, but Uber took it about 2 or 3 steps further in terms of radical simplicity, right? Order the car from your phone, and then when you're done, get out and walk away. That's amazing. It's amazing. Simplicity is the heart of innovation, and it is so powerful that I actually had a cabbie yell at me a couple weeks ago. I got out, I walked away, and he said, "Dude, do you think I'm an Uber? You need to pay." Market makers, Uber and Lyft, and, well, not even Sidecar anymore, right? This is a market which overwhelmingly rewards the early leaders who create these markets. However, and this is a really important but, although the early market leaders have a disproportionate share of the market, they do not enjoy permanently disproportionate share of the profits. And I'll give you a great example. One of the first physical markets that was completely and truly totally digitized was air transport. And in fact, in the late 90s and early 2000s, Sabre and Apollo, the main airline reservation systems, were actually worth more than almost every major airline. Right? And that was because they had this huge share. Well, what happened was the airlines, they got out of bankruptcy and they went direct to the customer. Right? And so now we mostly book our tickets directly with airlines, or we book them through these aggregators that connect directly to the airlines. Now, Sabre and Apollo haven't gone away. They're still big businesses, and they're still very profitable, but they no longer enjoy sort of monopoly power over the industry. And I would argue we will see that same evolution in the taxi market and other places. Cab drivers will go direct to their customers. So will everybody else, right? Technologies like the blockchain will make that possible. And then lastly, consumers. I'm a huge believer in the industrial internet. I think it's incredibly important and powerful, and I think it will produce more wealth than we can possibly imagine. But let's not make any mistake. When it comes to IoT, when it comes to technology innovation, consumers are way ahead of enterprises. They are much more nimble. They are much faster. They make decisions more quickly. I have to check with my husband, but I do not need to check with the CIO. We do not have a CIO in my house. Well, I'm the CIO in my house, right? But consumers can make decisions much more quickly. And so if we want to know where the industrial internet is headed, all we need to do is look at where consumers are going. Because consumers figure this stuff out first, then small business, and the last people to get it, sadly, are the Fortune 500. So, but that's good news if you're a consultant. There's lots of work for us. As they say, lead, follow, or get out of the way. I don't know where that quote came from, and I can't find any attribution, but it's always struck me as relevant, right? Being first in this market matters a lot. And with that, follow me on Twitter, connect with me on LinkedIn. You guys have been a great audience. Nobody fell asleep. Thank you so much.